Hello students, so today we are discussing about the signal description of 8086 microprocessor. So in pin diagram, total 14 number of pins are present. So the following signal descriptions are common for both modes, minimum mode and maximum mode. So first is AD15 to AD0. These are the time multiplex memory IO addresses and data lines. Address remains on the lines during T1 state, while the data is available on the data bus during T2, T3, TW and T4. So next pin is A19 by S6, A18 by S5, A17 by S4 and A16 by S3. So these are the time multiplex address and status line. During T1, these are the most significant address lines for memory operations. During IO operations, these lines are low. During memory or IO operations, status information is available on those lines for T2 state, T3 state, TW state and T4 state. Next is A16 by S3 and A17 by S4. So A16 and A17 are multiplexed with segment identifier signal S3 and S4, which combinedly indicate which segment register is presently being used for memory access as in below figure. So when S3 and S4 both have 0, it is extra segment. When S4 0 and S3 1, it is tag segment. When S4 1 and S3 0, it is core segment. And when both are 1, then it is data segment. Next, A8 to S5. So A8 is multiplexed with status S5 of the interrupt enable flag, which is updated at the beginning of each clock cycle. Next, A19 to S6. A18 is multiplexed with status S6. Then the bus high enable is used to indicate the transfer of data over the higher order, that is D8 to D15 data bus as shown in the table. It goes low for the data transfer over D5 means D15 D8 to D15 and is used to derive chip select of odd address memory band or peripherals. So bus high enable is low during T1 for read, write and interrupt acknowledge cycle. Whenever a byte is to be transferred on higher byte of data bus. The status information is available during T2, T3 and T4. The signal is active low. So then the signal is read signal. This signal on low indicates the peripheral that the processor is performing memory or IO read operation. The signal is active low. Next one is ready. This is the acknowledgement from the slow device or memory that they have completed the data transfer. The signal made available by the devices is synchronized by the 8284A clock generator to provide ready input to the 8086. This signal is active high. Enter into wait state and remain idle. Ready signal equals to 0 and no effect on the operation of mu, that is ready signal is 1. So INTR, that is interrupt request. This is a label triggered input and hardware interrupt pin. If any interrupt request is pending, the processor enters the interrupt acknowledge cycle. So this can be internally masked by resulting the interrupt enable flag. Next, NMI, non-maskable interrupt. This is a ACE-triggered input and hardware interrupt pin which causes type 2 interrupt. This interrupt is examined by a wait instruction. If the test pin goes low, execution will continue, else the processor remains in an idle state. The next one is clock input. The clock input provides the basic timing for processor operation and bus control activity. Then VCC, that is power supply, plus 5 volts. Then RESET, that is reset, if reset is high. Then the enter microprocessor is reset, then ground, 2 pins labeled ground, it is 0 voltage. So next one is minimum mode and timings. The pin function for the minimum mode operation of 8086 are discussed later. So M by IO bar, this is a status line logically equivalent to S2 in maximum mode. When it is low, it indicates the CPU is having an IO operation, and when it is high, it indicates that the CPU is having a memory operation. Next one is INTA bar, that is interrupt acknowledge. When this signal goes low, the processor has accepted the interrupt. Next one is address latch enable. This output signal indicates the availability of the valid address on the address data lines and is connected to latch enable input of latches. Next one is that DT by R bar, that is data transmit or receive. This output is used to decide the direction of data flow through the transceivers, that is bidirectional buffer. When the processor sends out data, the signal is high, and when the processor is receiving data, the signal is low. Next one is DEN bar, that is data enable. This signal indicates the availability of valid data over the address or data lines. It is used to enable the transceivers, that is bidirectional buffers, to separate the data from the multiplexed address or data signal. Next one is hold or HLDA. When the hold line goes high, it indicates to the processor that another master is requesting the bus access. The processor, after receiving the hold request, issues the hold acknowledge signal on HLDA pin. So in this middle of the text clock cycle, after completing the current bus cycle. Next one is WR bar or write. When it is low, the processor performs memory or IO write operation. So next is maximum mode operation of 8086. So first is S2, S1 and S0. So these are the status lines. The signals are connected to 8288. These are the status lines which reflect the type of operation according to the below table being carried out by the microprocessor. So when S2, S1 and S0 both are 0, all are 0, then it is interrupt acknowledge. When S2 is 0, S1 is 0 but S0 is 1, then it is read IO port. When S2 is 0, S1 is 1 and S0 is 0, it is write IO port. When S2 is 0 but S1 and S0 both are 1, it is halt. Then when all are 0, it is code access. When S2 0, S1 0 but S0 is 1, it is read memory. When S2 0, S1 1 and S0 0, it is write memory. And when S2 is 0, S1 is 1 and S0 is 1, it is passive state. So next one is lock. This output pin indicates that other system bus master will be prevented from gaining the system bus while the lock signal is low. The lock signal is activated by the lock prefix instruction and remains active until the completion of the next instruction. So when the CPU is executing a critical instruction which requires the system bus, the lock prefix instruction ensures that the other processors connected in the system will not gain the control of the bus. So next is QS1 and QS0, that is Q status. So these lines give information about the status of the code prefix Q. These are active during the clock cycle after 5. The Q operation is performed. So next is RQ by GT1 and RQ by GT0. That is request or grant pin. So these pins are used by the other local bus master in maximum mode to force the processor to release the local bus at the end of the processor current bus cycle. Each of the pin is bidirectional with RQ by GT0 having higher priority than RQ by GT1. So next is addressing mode of 8086. Addressing mode indicates a way of locating data or operands. Depending upon the data types used in the instruction and the memory addressing mode, any instruction may belong to one or more addressing mode, or some instruction may not belong to any of the addressing mode. Thus, the addressing mode describes the types of operand and the way they are assessed for executing an instruction. So here, we will present the addressing mode of the instruction depending upon their types. The addressing mode for sequential control transfer instructions are explained as follows. So first one is immediate addressing mode. In this type of addressing, immediate data is a part of the instruction and appears in the form of successive byte or bytes. For example, move AX, 0005H. So in the above example, 0005H is the immediate data, and the immediate data may be the 8-bit or 16-bit in size. So next is direct addressing mode. In the direct addressing mode, a 16-bit memory address, that is offset address, is directly specified in the instruction as a part of it. For example, move AX, 5000H. So here data resides in a memory location in the data segment whose effective address may be computed using 5000H as the offset address and content of DS as segment address. The effective address here is 10H into DS plus 5000H. So next one is register addressing mode. In this register addressing mode, the data is stored in a register and it is referred using the particular register. All the registers except instruction pointer may be used in this mode. For example, move BX, X. So next one is register indirect addressing mode. Sometimes the address of the memory location which contains data or operand is determined in an indirect way using the offset registers. This mode of addressing is known as the register indirect mode. In this addressing mode, the offset address of data is in either BX or SI or TI register. The default segment is either DS or ES, that is data segment or extra segment. The data is supposed to be available at the address pointed to by the content of any of the above registers in the default data segment. For example, move AX, BX, where the data is present in a memory location in DS whose offset address is in BX. The effective address of the data is given as 10H into DS plus BX. Next one is 8086 instruction set and assembler directive. The 8086 microprocessor supports 6 types of instruction. They are data transfer instruction, arithmetic instruction, bit manipulation instruction, string instruction, program execution transfer instruction, that is branch or loop instruction, and processor control instruction. So first one is data transfer instruction. These instructions are used to transfer the data from source operand to destination operand. So all the store, move, load, exchange, input and output instructions belong to this group. So general purpose byte or word transfer instructions are move. Move means copy the byte or word from specified source to specified destination. Then push. Push the specified word to top of the stack. Then pop. Pop the word from top of the stack to the specified location. Then push A. Push all registers to stack. Pop A means pop the word from stack to all register. Then XCHG means exchange the contents of the specified source and destination operand, one of which may be a register or memory location. Next, in reads the byte or word from specified port to the accumulator, and out means sends out a byte or word from accumulator to a specified port. Next, LEA means load effective address of operand into specified register. LDS, load the DS register and the other specified register from memory. And LES, load the extra segment register and other specified register from memory. So next is LAHF.